Hey team, this is Mr. True. We're just quickly going to go over a few things and introduce our organic chemistry. So organic chemistry is really an important area of study for chemists. It's the root of making pharmaceuticals, but it reaches all the way back into fossil fuels, and so that obviously has a great bearing on Alberta and our economy. Before we get into organic chemistry is the study of containing compounds, but we're going to be specific here. We're going to say that they have to be carbon containing compounds, but they're not inorganic compounds. And inorganic compounds have carbonates, cyanides, carbides, and oxides of carbon. So these are going to be like ionic compounds typically, or they're just inorganic compounds. So carbonate is like the carbonate ion, cyanide ion, carbides are an ion of carbon. They're pretty rare. But carbon dioxide or carbon monoxide are all inorganic compounds. So this is a fairly common testing area. What is organic and what's not organic? If it's got any of those components in it, it is not an organic compound. If it is an ionic compound, it is inorganic. We're going to start off by looking at alkanes. So alkanes are saturated hydrocarbons, and saturated hydrocarbons only have single bonds. So they're fairly easy to spot if you can see the structure, because there are no double or triple bonds. And we are going to see some patterns that go along with them. If we were going to go back to our Chem 20, we'd know that they're tetrahedral. They're kind of an AX4 organization. So methane is CH4, and it's going to look like this. It's going to have that tetrahedral shape, where we get the carbon is like so, and so in three-dimensional shape, according to Vesper theory, it's going to be a tetrahedral shape. Well, all of our alkanes, because they're saturated and only have single bonds, are going to have that tetrahedral shape around them, and because of that, they're going to be nonpolar molecules, and those nonpolar molecules are only going to have London dispersion force. And so one of the things that comes up pretty frequently in organic chemistry is the properties of the organic molecules. And so alkanes, because they have no polarity, or they're nonpolar molecules, they only have London dispersion force, and so their melting point and boiling point is basically going to depend only on London dispersion force. And so the more London dispersion force, the higher the melting point and boiling point. So typically, the London dispersion force is mostly related to the size of the molecule. So the bigger the number of carbons and hydrogens, the more of those dipole moments that cause attraction between the molecules, and the higher the melting point and boiling point. If you have molecules that are the same size, so they are isomers, structural isomers, that have the same number of carbons and hydrogens, then we're going to find that longer, straighter hydrocarbons have more London dispersion force, and probably only a little bit more, but more London dispersion force than a balled up shape. So if we had something that was a very long molecule compared to a molecule that had lots of little branches and they were the same size, we would expect that the longer molecule would have more London dispersion force, because basically it's got more surface area, more opportunities for the protons in one atom to be attracted to the electrons in a different molecule. Alkanes are found in nature in fossil fuels, so we recover those as natural gas or as coal or petrochemicals. Obviously a big component in our economy. Alkanes have a low solubility in water, but that's not surprising. They're nonpolar molecules, so all nonpolar molecules typically don't dissolve well in water. Like dissolves like, so nonpolar hydrocarbons will dissolve with other nonpolar hydrocarbons, but they won't dissolve with polar water. So typically, most hydrocarbons, including alkanes, are not going to dissolve well in water. That's the sort of the background for organic chemicals. We want to know their properties, relative boiling points. How do you identify if it's organic or inorganic? We'll have another video where we go into naming and structures of molecules. It'll take a little bit longer.